Ladies and gentlemen, welcome back to the part 2 of Adventures of Hardware Hacking series, a hardware hacking video. So, let me continue. So, hardware attacks when it comes to UART. So, what is basically UART? UART is full form is Universal Asynchronous Receive and Transmit. So, the visual inspection is the most common way to detect what kind of UART is there. We're going to discuss about we will be also knowing that what kind of continuity test with the multimeter can be done to find out which kind of UART is there. Also, it also includes some soldering of it, because you need to solder those pins with the header pin and make the connections with an RS2 thread 2 or a USB to TTL connector, which we recently discussed. We are going to give a specific baud rate. For example, depending on the device, it's like 115 to 009600, or any of these standard baud rates will be used. And we are going to get the root shell with a software uh, on called Minicom, or in some cases, if you are using Windows, it's putty or things like that. And generally, on these devices, the root is root username is admin mostly, and you're gonna have the root shell of that device. So consider this is your first PCB, which is the target device, and this is the tool which you are using to hack into the PCB. So this is how you make the connections. You take the TX, connect it with the RX, and you make the RX connected to TX, RX to TX, TX to RX. That's it, and ground to ground. So there are only 4 wires, and that's how you make the connections. So now comes the most fun part. It is JTAG. JTAG is generally known as for JTAG was actually implemented for some boundary scanning methods, but Joint Test Action Group is a type of it is also a type of communication protocol. It also can be found out by using a visual inspection. By that I mean you just look at those test pads and you can conclude that what kind of communication protocol is there. In most cases, in most cases you can be successful while just with the visual inspection, but it is not necessary. However, JTAG pinouts can be seen just by looking at those set of pins, and that's how you can communicate and look into these things. Now, connectors with jumpers. Jumper wires are the type of wires which can be used and which can be after the soldering. You have to use jumper wires and use it with a breadboard in order to do some processing and to do some connections with it. And you also have to do soldering with the flux, if and you need to make sure that you're not burning up your hands or even burning up the select line or the traces of the PCB or the pin or the wire or the connector which you are actually using to hack into the device. And there are some header pins which you need to take care. Like I said, you need to use header pins as well along with the wires. So you can use softwares like OpenOCD or URJTag, and uh, you can have the access to this memory of these particular devices chips and play around with that. So this is a type of hardware attack which includes JTAG pinouts, and there are different types of JTAGs. So it has 10 number of pins, like in some cases there are 10 pins generally. There are also pins, there are also places where there are 20 kind of pins. 20 number of pins are 20. So it all depends, and make the connections like you, this is how you make the connections and everything. And so there's another protocol called SWD, which stands for serial wire debug. And serial wire debug is in most cases as used in most of the STM32 based microcontrollers, but that depends. And these are the pinouts of it. It includes 10 pins. And I'm not sure if you guys are able to understand, but let me focus on how you can read these particular chips, how you can read these particular pins along with the information which is given on the data sheet, and how these pinouts are actually being used. So consider this. Let me minimize. I like to keep the camera on, guys, because that's how you guys will be enthusiastic to learn by looking at my expressions, and like this is how I move my hand and do a lot of things. So just minimize, yeah. So VCC. So uh, I'm not sure if you guys are able to see, but these are the pins. 1, 2, 3. There's a gap here, and 4, 5, 6, 7, 8, 9, and I think the seventh one is missing, so these are 10. So the 10th one is reset. So this is how you read into these pins, guys. If you can see, in order to understand which one is VCC, which one is the first pin, there is a mark given here. You can look at this particular hole out there. In most cases, whenever you are reading the number of pins, whenever you are doing the number of pinouts given on a specific device, you just need to focus on the hole and the mark which is given anywhere. Whenever there's a mark, that means that particular pin number is VCC or the number one. And in most cases, VCC is number one, pin number one. So now you guys know how to read the number of pins completely. So this will be pin number one. This will be 2 as per when you look at the data sheet, you can see this image. So 1, 2, 3, 4, 5, 6, 7th is missing, 8th, 9th, and 10th. There you go. This is how you're gonna make the readings. And this applies to JTAG here. This applies to UART, and this applies to other places as well. Now you guys might be thinking, oh, I was explaining about the 10 pin interface. This only has 8. Where is this thing gone? So now this could be understood in a much more in-depth manner, because you need to know what about like what if this is not a JTAG? What if this is UART? It could be UART or it could be JTAG. See guys, I'm not gonna spoon feed you. Now I told you how you can use these kind of techniques. However, it is now your job to understand and do some visual inspection that what kind of test pads are these. I can even sort of confuse you guys by adding a UART kind of image here, a UART kind of image here, and name about JTAG. So I want an answer from you guys. What do you think? This is a UART or this is a JTAG? Okay. So, but I already explained about the JTAG thing. This is how it looks like. You guys can just search for what kind of JTAG pins it is. And okay, I think you got the answer now. Any, anyways, so guys, let me explain about the failures and the hardware teardowns. what kind of failures which a person can face, right? So I'm not going to go in depth this time, but there are certain kinds of failures which every single hardware hacker has faced while playing around with devices. You, the more number of failures, the more number of cool experiences. Let me be clear with that, guys. So I am not sure if I'm going to discuss each and every single one of these failures because I don't want to bore you guys, and it will be complete. It will be a bit off topic, but I'm going to discuss about some of the mistakes which can be avoided. So burnt UART on router. I burnt a UART on the router, and I was missing UART on a mouse. Like I figured out that there was no UART in a particular mouse, so I ended up breaking that device because I was thinking that it's a UART on a particular printed circuit board, and it turned out to be something else, and the entire USB to TTL connector got burnt thanks to the USB hub that my motherboard of my device was not burnt. Otherwise it would have been a complete mess for me. And I damaged my RTL SDR, the real tech software defined radio, accidentally with it, with some of the mistakes which I did. I also damaged the alpha card, and I also failed to build an EMF detector for sensor based attacks. So I did a lot of failures, guys. I mean, we all have a lot of failures, and the main important factor is what are you going to do with those failures. You're going to make the best use out of those failures, and that's how you're going to learn. So now, hardware recon. Now, how would you do a hardware recon, guys? Let me think. I mean, let me make you guys think. Now, before even coming to this slide, you can just get back, take those set of knowledge, and use it to do hardware recon level things. Now, what I'm actually trying to say is hardware recon can be done by finding pinouts with multimeter. Just do a continuity test. Just use a digital microscope in order to understand what kind of protocols is there. Use IC identification, what kind of ICs are actually being used, know what kind of ICs actually are there into the market. You see, that's why I was focusing much more on IC identification in the starting with lectures, which you guys might have thought to skip. So get back to those videos and look at those. And data sheets as well. You guys must be knowing how you can find a particular data sheet of a particular chip, and how you guys are going to read those particular data sheets. And most important thing is to dump the firmware out of those devices. Once you dump the firmware, I'll tell you what you guys can do with it later on. So that's it from me, guys. Thank you so much. I hope that you guys enjoyed this video. Thank you.